Do you have a lot of data? Have you collected a lot of data over the years? What do you do with it? Have you analyzed it all? Do you know what to do with it? There's a new and relatively emerging field called data analytics and visualization. It's run by computer scientists. It's absolutely phenomenal field. Zhonghao Liu is a computer science PhD student at the University of South Carolina. We approached him and his advisor. What they've done is truly breathtaking for us. We're still learning how to use the information that we're getting from it. You know, as humans, we remember things in groups of 3 and 4. If you don't believe that, think about your phone number. 3 digits, 4 digits, in a series of 3 sets of numbers. How about when you get into millions of data? All right, that's what this project is about. Thank you, Zhonghao Liu.
Thanks, Mr. White. And this is a project we did in last summer and take us about 1.5 months. So it's not a very long-term project, but we still get some very interesting information and result. Okay. And Dr. Hu cannot come here because the campus is open and he needs to teach, so I'm here. Yeah. So this project is sponsored by the SCDOT, and it's a cooperation between our university and this NOCO department. So I will talk about 2 parts. The first part is about the project and system we built for SCDOT. And the second part is because we don't have a long time to focus on this data, but we still have some vision for this kind of data and for this kind of problem. So we propose some future work you may be interested to apply on your own data or your own department. So talking about data, what we have, and Mr. White came to us and majorly we have 2 kinds of data. It is a daily work report. It describes how department uses equipment. And the second is service tickets. It's about the technician maintenance equipment. So we have about 2 million daily work reports and 1 million service tickets. And in each service tickets, we have about several labor tickets because there may be several technician laborers working on this same job. So what do we want? Because at first, John came to us, brought so many data in his mobile disk. Me and Dr. Hu, we have no idea what we're gonna get from this, and previously we don't touch this field. We usually do with images and biology or chemical data. So we asked White, what you expecting from this, and he gave us this answer. I don't know. Yeah, it's actually, and yeah, I think Dr. Hu and me both think this is actually the correct answer. This is a correct answer for data mining. If we have a lot of data, we never touch this data, and of course we don't know nothing from it. And if we can find something interesting or useful from this data, that's the value of data mining. So actually that's a correct answer. So actually I think in your department or states, you also have a lot of data. It's in your server, government server, or in your own PCs. There are just some 1 or 0 files on your disk, but actually maybe you never see them as some interesting stuff, but actually in our eyes, I think data are the unseen gold mine, and it's just like the gold in the Hobbit, the Smaug. I'm not saying Mr. White is the Smaug the dragon. I'm just saying actually in your department, in your state, you have this unseen gold. So what we did, actually, At first, Dr. Hu said maybe we should give a detailed report of what we found or what we did. But at last, we talked and discussed with Mr. White. We think we should deliver a system application. He can query the result by himself, and he can give different input, and so he can get the result. And also we make the system an interactive system, so the result is in an interactive environment, so it's easy to understand the result. And we name it the SADOT Equipment Insight System. So actually it's just a web application. It's just you use your browser and you can see the data, you can query the data and give different criteria or different like dates, different type of equipment, what you want to query, and you can get the result. So there are some features about this system. First is big data business insights, because for the data itself, Mr. White gave us is a lot of Excels, so it's just like tables. But in this system, we visualize it and we organize them in a reasonable way and a readable way. So it's easier for you, for the users to understand what are the data, what the meaning of the data and what the trend of data. And we use a lot of visualization techniques to the data itself and the result, because it's easier for human to fill in the trend or the insights through image, not a lot of like thousands of rows of numbers, I think. And the third one is the system can uncover some expected or unexpected patterns, which means like we have the outlier functions. We can outlier the technician, find the outlier crew shop or outlier equipment usage, and that's a feature of our system. And our final feature is because you can query a lot of based on a lot of criteria and condition. So I think our final goal is to give the advice to the Mr. White to see if what's going on in your department, what's going on in your equipment usage and maintenance. So it can generate actionable decision to optimize business process. An example is we compare the same task among different repair shops and to see the efficiency of each shop. So that may help the administrator to decide what next we could improve the efficiency of different shops. So it's just like how the system looks like. We have, and I think I forgot to talk about how many equipments in our data. There are like 12,000 equipments in this total data. So now I will talk about like several feature functions of this system. First is equipment detail analysis. So in this 12,000 equipments, it was categorized. It was in different type of equipment. So this function this function is for each type of equipment. If you could see here, this key ID represents one type of equipment. So in this case, we choose the type of line. I still cannot remember. It may be truck, I don't know. And so the system, when you choose a type of line, so we suppose it's truck, it will analyze the data and give you this result. So it may look like messy, but I will explain to you. For each bar in this figure represents a specific equipment in this type of truck, and each bar you see the blue and there are orange. The blue stands for the number of working hours of this equipment. And this orange color represents the downtime, which is stay in the maintenance shop. So, and we sort them by the ratio, working hours divided by the downtime hours. So the equipment on the left, so most of them, or some of them even never work, they stayed at the repair shop. So on the right, they are hardworking equipments. They are heavily used, and they have a large part of blue part. And the green dots above each bar is the age of this equipment. So once we have all the information, we draw some supporting lines. So this lines, all the green dots above, below this line is older than 5 years in this DOT. This line, I think, I cannot clear, I think is 10 years. This line is older than 15 years. And this vertical supporting line is all the equipment on the left of this supporting line that its downtime hours is larger than the working hours. So that's all these equipments stay, most of them time are in the maintenance, not working. So what we interested is in this square, I think, this square. So these equipments are old, but they didn't work a lot. And in the application, it is an interactive chart. So if you stay your cursor on these dots, you can see the specific number of working hours and downtime hours and the number of this equipment. And then you can choose in this field, you can choose a specific equipment to see what happened to this equipment. For example, we choose one of these interested equipment. You can see the details. This is how many hours stay in the repair shop, how many hours it was used. And we can see the status, it was disposed. So maybe that's reasonable for this equipment. And also, if you analyze one specific interested equipment, we also give the result of the tickets analysis. This is for all the tickets of this maintenance tickets of this equipment. We analyze what's the frequency of all the different kind of maintenance job. So we may interested in the most frequent job to see what happened to the equipment. So based on this information, we may refer how it was used. And also we give a word cloud of this maintenance from the, so you can have a direct feeling what's going on, what's happened to this equipment. And then we give the result of this equipment of its downtime hours and working hours of each year. So it's much more specific. You can see along the years how the equipment was used, how it was maintained. Next is maintenance analysis. Here we give some information about for different kind of, this is for different kind of equipment. What's the cost we paid for this type of equipment along the years? So we may see some. So based on the result, you can see just 3 or 4 type of equipment occupied most of the maintenance fee. And this is for all the, we show all the, this is all the type of equipment. It's too many. And this is the cost, all the cost of the 10 years data. So this is another way you can see that this supporting line, all the type of equipments on the left side of this supporting line, the total cost of this type of equipment occupied 80% of the total maintenance budget. So so this figure may give you what type of equipment you should focus on, and maybe for this type of equipment you should have much more care. And this is for the maintenance of different kind of activity. So you see, and what the cost for this kind of activity. So the first one is repair, and the second is, I cannot say, is install something. Yeah. So the first one, of course, is repair something of equipment, and the second is install something. And this is just the intuitive function of all the cost, all the maintenance cost through different years. And also another important function is outlier detection. We want to find the outlier among shops, among technicians. So first one is outlier crew. So it's the technician. So when you select a data range like this, whole from 2008 to 2014, it will analyze the working hours of all the technicians we have in this data. So you can see, so you will see during a specific time range, which technician works a lot and which technician just maybe works few hours. But of course, there are something you should consider is that the data itself may be not so accurate, but you can see some trend, or you can see what's going on. And also it's an interactive figure, so when you stay your cursor on this figure, you can see who is this technician. And once you have a interested technician, you can from here to choose the technician and get the details of all the service tickets he or she involved. Yeah, but I didn't post the pic. The next one is outlier equipment. So similarly, when you select a time range, you will see, and also we should limit this to a specific type of equipment. And you will see in the same type of equipment which cost a lot during this time. And I think also we draw a supporting line. It's 80% of the total cost during this time. So you will see there are some equipments may be heavily used, so it needs a lot of maintenance. And also you can check the details of this equipment. And we list all the information of each equipment, include the total cost during this time and how many maintenance tickets it associated with, and how many working hours it was used. And next one is outlier shop. So there are many crew shop in the state, and we want to see which how many hours it worked in a specific time range. So similarly, you choose the time range, you will see the how many task hours this shop worked, and how much money it costs during this time. Next one is shop service analysis. We want to compare for the same type of task. Like here you can see the activity code and the component code. So the two codes combination is a specific type of task. And then you can analyze for the specific type of equipment. Then the system will analyze it. It will give the result. So each bar is a shop. So the meaning is for this specific type of activity, for the specific type of equipment, this shop's average labor cost, average part cost, and average working hours. So from here you can see for the same type of task, who is much more efficiency, which shop is much more efficient. So this gives you the feeling and what's going on during so many shops. Yeah. And because we don't have so many time on this project, but we think, and Mr. White said it should be the pioneer project in the DOT. So we may think in your states or in your department, you can also collect your data and do some analysis. It may help you understanding in so many past years how the crews, how the shop, how the equipment worked. And if you have this data and do some analysis, it may help you scheduling your task, your crew distribution, and how you balance the works between different shops. And next fancy work maybe you can do is you can repair shop efficiency prediction, because you know how many crew you have in a shop, and based on the history data, you know the average hours and average cost for the specific type of job the shop may take. So you can predict in future if you add more people or take some people out, what's the hours or cost it may take, and it can help you do the budget. Yeah. Also, based on the equipment detail analysis, you can have a feeling if the equipment maybe need to retire, because most of the time is in the maintenance, not in working. Yeah. So, thanks.
We have any questions?
I'm still learning how to use the results. I just had an SSD installed in the machine 2 months ago. It takes too long to run off of a hard drive, way too long. This is the first opportunity. When we use a piece of equipment, when a piece of equipment is used, and then they break it. It goes in the shop for repair. And then it's used again until it's broken again, or another service interval. And then it's broken again, another lump of repairs. That's where I want to take this analysis. Let's take a look, and this is the first opportunity I've seen that we're taking the maintenance or usage records and coupling with the service records. Let's see if we can draw any conclusions from that and see, is it this operation that causes the most of the repairs on the backhoes? Is it this operator? Is it this time of day? Is it working in this location, this county, this day of the week? Any of that. I mean, we could actually couple it with meteorological information and see if it's because it rains or because it's 30 degrees Celsius. I don't know where we could go.
Any other questions? Not, thank you.